Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at the number systems and taking a look at the domain of a particular function and see which appropriate groups of numbers within the number system fits that domain constraint. So the question reads, which domain is most appropriate for a function that represents the number of items f of x placed into a laundry basket each day x for the month of January? Okay, so you just have to recall that the domain represents the inputs, acceptable inputs. In this particular case, if you think about it intuitively, you can determine what the correct answer is. All right, so f of x is the function, all right, and the domain is basically the acceptable x values that can be inputted into the function. All right, and this x represents the number of clothes you place in the laundry basket each day. Okay, number of clothes or number of items. It could be clothes because that's what you place in the laundry basket. All right. Okay, so before we get started taking a look at which of these sets of numbers is an appropriate domain for this particular scenario, let's refresh our memory on what these sets of numbers represent. All right, so to do this, we're going to go to our website, Mathgotserved.com. We're going to go to Algebra 1. Let's take a look at the Chapter 1, which are the fundamentals. Under sets of numbers, all right, so we're just going to take a look at whole numbers, integers, rationals, and irrationals, all right? There are other numbers sets, as you can see here. But we're focusing on those four because those are the ones on the options. Those are the options that we have in the question, all right? Okay, so whole numbers. Whole numbers are also known as counting numbers. Think about it for a second. Whole numbers are counting numbers from zero, okay? The difference between whole numbers and natural numbers is that natural numbers does not include a zero. So whole numbers are counting numbers from 0, 0, 1, 2, 3, okay? Integers are whole numbers and their opposites. So you have your counting numbers from 0, 1, 2, 3, which are whole numbers. And then when you take the opposite of 1, 2, 3, you get those negative counting numbers. Those are together form your set of integers. All right. And then rational numbers are any number that can be written as a fraction of two integers. Okay. All integers are rational numbers because you can write every integer as a fraction. In decimal form, they are repeating or terminating decimal. Okay, so for example, if you have 1 over 3 is 0.333 repeating, that's a rational number, or 0.5, it stops there for 1/2, that's a terminating decimal. Those all represent rational numbers. All right, irrational numbers are basically the set of numbers that cannot be written as a fraction of two integers. Okay. In decimal form, they are non-terminating and non-repeating. All right, they just go on forever without any clear pattern in the digits. All right, so let's go back to the question. All right, and we're going to work through them one by one. All right, so let's start with the first one. So the first one is the set of integers. Do you remember what integers are? We just talked about it, right? Integers are counting numbers and their opposites, including zeros. So, example of integers are -3, -2, -1, 0, 1, 2, 3. Whole numbers and their opposites. Okay, so would this be an acceptable domain for this particular problem? So in order for it to be acceptable, every element of this set must be reasonable or should make sense. Does everything here make sense for the number of clothes that number of items you have in the basket? The answer is no. This one is not appropriate. Not appropriate. So you might wonder, why is it not appropriate? Well, it's not appropriate because you cannot put negative clothes in a basket. All right, you can only put positive number of clothes. You can't it doesn't make sense to put -2 shirts in a basket. That makes no sense. All right, so number of items or clothes, think about them as clothes, cannot be negative. All right, let's move on to the second one. The second option is whole numbers, also known as counting numbers. The name alone gives it away. So whole numbers are counting numbers starting from 0. So you can look at them as 0, 1, 2, 3. Now, do these numbers make sense for counting the number of items in the laundry basket? Absolutely. You could have 0 or no items. You could have just one shirt, 2 items, like a shirt and a pair of pants, 3 items. You see, counting numbers starting from 0 makes perfect sense. These are acceptable numbers that represent the number of clothes that go into a laundry basket. All right, so this guy right here, this set of numbers is appropriate. Appropriate. Whole numbers can be used to count or represent the number of laundry items. Whatever whole number you pick, it makes perfect sense when you, in the context of the number of items you have. All right. Okay. So let's take a look at the others. We already know what the answer is. The answer is option number 2. Let's take a look at the others and to discuss why they do not make sense. So option 3 is rational numbers. Rational numbers. What are rational numbers? Rational numbers are numbers that can be written as a quotient of 2 integers, terminating decimals, or repeating decimals. All right. So for example, we have 1 over 2, 0.5, 3 is a rational number because you can write as 3 over 1, 0.2 repeating. Okay. Is this appropriate? Certainly not. This is not appropriate. Why is it not appropriate? Well, under normal condition, right? Everyone wears whole clothes, right? You don't wear half a shirt, although some people do. But normally, when you're counting, you say, well, I have half a pair of pants in there, or I have half a shirt. That doesn't make sense. You count it in wholes, right? So this is not appropriate because fractions, for example, fractions cannot be used to count the number of laundry items. Think about going to the dry cleaners, right? And then you say, how many items do you have? I have just half a shirt, so you should charge me half the amount. That won't work, right? They count it using whole numbers, either 0, 1, 2, 3. You can't use fractions to represent the number of laundry items. All right, and then the last one, number 4, is irrational numbers. Irrational numbers are numbers that cannot be written as a quotient of 2 integers. They are non-terminating. Non-terminating and non-repeating in the decimal expansion. So root 3, for example, is a radical number. If you write in decimal form, it is not terminating. All right, or pi goes on forever without any pattern, or the transcendental number e. Okay, is this appropriate? Certainly not. This is not appropriate, right? Because radicals, just pick one example. Radicals, for example, radicals cannot be used to count or represent the number of items. Number of items. All right, so we see that the answer to this question is option number 2. Whole numbers are an excellent domain values to represent number of items, tangible physical items that you count. Thanks so much for taking the time to watch this presentation. Don't forget to support our channel by letting us know what you think about the tutorial in the comment section below. or asking any questions, or let us know how your day is going. Tons of support resources can be found at mathgotserved.com. Do check it out. Thanks again for watching, and we'll see you in the next video. Goodbye.